Today we're talking about lines and how the lines will change when we mess with their slope or when we mess with their y-intercepts. The first thing we're going to look at is the parent function. So right off the bat on each of these graphs up top, we're going to write our parent function. We're going to draw our parent function. You might want to write down that these are the parent functions, or sorry, that this is the parent function if that's not something that you already knew. In order to graph this, we need to know that the slope is 1 and that the y-intercept has got to be 0 because they don't write anything else, right? So the slope is 1, the y-intercept is 0. So first graph over here we go. If our y-intercept is 0, here's my first point, and my slope of 1 means I'm moving up 1 and right 1 as we move along. So here is my original parent function. All right, y equals x. So when we change the slope, what happens? Well, just as an experiment, let's change the slope. Right now the slope is 1. Why don't we draw a line where we have a slope of 3? All right, if my slope is 3, then instead of going up 1 over 1, I'm going to go up 3 over 1. And I'm going to draw my new line. Here we go. All right, this equation here was y equals 3x. So what happens when I change the slope from 1 to a 3? Can we agree that the graph got steeper, right? Isn't that red line definitely steeper than the blue line? Okay, sure. Let's try another one. What if I go ahead and I graph y equals 1/2 x? So now my slope is 1/2. So I'm going up 1, right 1, up 1, right 1. So this is my new slope. So this line looks like this. All right, y equals 1/2 x. All right, so we've got a slope of 1/2 and then a slope of 1 and then a slope of 3. And what happens to each of those? Isn't it getting steeper as we go? Yeah. So let's make this observation. Changing slope changes the steepness of the graph. All right, and since we had the green line was the least steep, and then the blue line, and then the red line was the most steep, I think we can kind of safely say here that a bigger slope will give you a steeper line. All right, the only thing that we haven't really talked about in this case is what about a negative? So I'm going to graph a negative slope now, and I think I'll graph a negative, let's do -2 for my slope. So going down 2 over 1, so here's my negative slope line. Alrighty. This is y equals -2x. And this is still fairly steep, right? The yellow line is definitely steeper than the green line. It looks a little bit steeper than the blue line, but not as steep as the red line. So what did the negative even do? Right? We still kind of could have predicted the steepness if we had ignored the negative. So really all the negative does is change the direction. The negative just changes the direction. Okay, so we still can kind of ignore the sign if we're talking just about steepness. All right, biggest thing to take away from this is that the bigger the slope, remember ignoring the sign, the steeper the line. Now, what if we start messing with the y-intercepts? Well, let's take a look. I'm going to start with my parent function again. So my original line, my first line on this graph, has a y-intercept of 0 and a slope of 1. So here we go. All right, we have y equals x. So I want to mess with the y-intercept. Right now the y-intercept is 0, right? So what do we do if we get a y-intercept of, I don't know, 5? All right, well, let's graph it and let's look. Here's 5. My slope is still 1, right, because I didn't mess with my slope. So here is my new line. All right, this is y equals x plus 5. So what happened? Well, looks like we just moved the whole graph straight up 5. Right? Just looks like we moved the graph straight up 5. Let's see if this kind of sticks. Let's try graphing y equals x minus 7. So I'm going to start here at 7. My slope is still 1. Okay, let's see here. Here's my line. Y equals x minus 7. Okay, yeah, again, I have a graph that looks exactly the same, right? It's just moved down 7. So if I start changing the y-intercept, all it does, right, all changing b does is shifts the graph up or down the y-axis. Okay. Under this box, we have parallel lines. What do we know about parallel lines? Well, yesterday we talked about how parallel lines have the same slope. So instead of drawing a whole bunch of parallel lines, can we just recognize that all those lines up there are parallel? Right? Parallel lines have the same slope. What was the slope of all those lines we just drew? Weren't all the slopes in this graph just 1? Right? They all have the same slopes, which makes sense, right? Because they definitely look parallel. So parallel lines have the same slopes, and also we know that they never intersect. All right, last but not least, let's talk about perpendicular lines. Now, I really think the best way to talk about perpendicular lines is through an example. So instead of drawing the parent function, I'm just going to draw a random function here. I want you to, if you're following along, to draw the function y equals negative 2x plus 1. So here's my y-intercept, and my slope is negative 2. So that is going to be my line here. All right. All right, so here is my line. What I want to talk about is that perpendicular lines have opposite reciprocal slopes. Okay, perpendicular lines have opposite reciprocal slopes. We also know that they intersect at a 90-degree angle. So let's talk about a quick example. Right now, the slope that I drew on that red line is negative 2. So if I have a slope of negative 2, what is my new slope for a line perpendicular to this? Right? I'll do it in a different color even. Right? What's my new slope going to be? Well, we have to understand what the word opposite means. Opposite means different sign. So this positive is now going to become, this negative is now going to become a positive. And the word reciprocal just means flipped. All right, so how do you flip this 2? Well, you need to remember that there's a 1 under there that doesn't get written. And so the 1 is now on top, so 1 over 2. So a negative became a positive, and a 2 over 1 became a 1 over 2. So this is my new slope. So for my new line, I'm going to have y equals 1/2 x. Now, I don't know the y-intercept specifically, but any slope of 1/2 will be perpendicular to this red line that I drew. So what I want to kind of do is I want to kind of have a little bit of a challenge here, and I want you guys to figure out what's the slope going to be of a line, what's going to be the slope of a line that goes through that blue point I just drew. So I want you to make a line go through that point, and we're going to come up with the y-intercept for our equation. So I want you to go through the point 3, 8. And this is just a kind of a review of what we did yesterday. How can I figure out the slope, not the slope, the equation of a line perpendicular to the red line, but that also goes through that blue point? And we definitely already know the slope is going to be 1/2. Okay, well, if we know the slope is 1/2, then we just need to use the slope, up 1 over 2, right? Slope is 1/2. Now I kind of want to go toward the red line, so let's go backwards here. Down and left, down and left. Oh, there's my y-intercept, right? So here is my new line. And the equation for this line has a y-intercept of 6. All right? Again, that was just kind of a review from yesterday. The biggest thing, though, to remember about perpendicular lines is that they have opposite reciprocal slopes.